Friends, today we are going to see an important topic, that is reaction mechanism. Generally, in organic chemistry, reaction mechanism and isomerism are the two pillars for that organic chemistry. If you have a clear idea about these two topics, definitely you will get a better idea about that organic chemistry. Come on, let us go and analyze what is reaction mechanism. Reaction mechanism is nothing. Chemical equation. Chemical equation represent a symbolic representation of a chemical chain. So what are the chemical equation represents? Here, reactants. Reactants, it gives product. Right? So that reactant, it gives product. So what are the reactants will be available? So the reactants available, one, it is a substrate, the other one, it is reagent. One, it is substrate, the other one, it is reagent. So these both combine and it gives that product. What product? First and foremost, you will get an intermediate product. Intermediate product. Then finally you are getting a final product. Okay, that step by step reaction changes, that means step by step process taking place, that is called reaction mechanism. Okay, let us go and identify how that reaction mechanism takes place. First and foremost, I would like to mention here, what do you mean by reagent? Reagent, it is nothing. Reagent is a substance which is going to attack the substrate. What do you mean by substrate? Substrate is the substance which is getting attacked by the reagent. Right? Okay. So, these reagents are two kind in nature. One, it is electrophile, the other one, it is nucleophile. What is it? One, it is electrophile, and the other one, it is nucleophile. Electrophile, and this is nucleophile. Okay, so as I mentioned, electrophile actually electron poor, electron deficient, electron wants, actually what it is, electron poor, electron deficient. Okay, so here nucleophile, just the opposite, rich, electron rich, electron donor. Okay, so now, anyway, as I mentioned, a reagent which is going to attack the substrate. So these are the two kind of the substance which is going to attack. Now, which is going to attack the substrate? That is the main point. As that electrophile which is going to attack the substrate, where it is going to attack the substrate? Anyway, it is a positive charge. Where it will go and attack? It will go and attack the negative charge of that particle. Right? Okay, so electrophile which is going to attack the negative charge of the particle. As it is going to attack the negative charge of the particle, so automatically electron density will be higher. Where the electron density will be higher? Here in this point, electron density will be higher. It will go and attack the negative particle of the substrate only. Why? Because it is a positive charge. Now, next one, nucleophile. Nucleophile, it is a negative charge or neutral. Okay, so as we are talking about the nucleophile, negative charge or neutral, I'll give the example. OH minus, Cn, and H2O, it's a neutral molecule, right? So this negative charge which is going to attack the substrate where there is a positive particle. So here, which is going to attack the positive particle means here electron density, what it is, as I mentioned here, that electron density will be higher, but whereas here electron density will be lower. That is the main point. Hope you're clear with that. What is reagent? That is going to attack the substrate. What are the two different kind of reagent? Electrophile and nucleophile. Electrophile, it is what it is, electron poor, electron deficient, bonds. Okay, now this is going to attract the substrate of what? Negative charge of that. Okay, so that when it is going to attack, so naturally it is having electron density will be higher. Whereas nucleophile, which is going to attack the substrate of the positive particle, so electron density will be lower. Yes, it is clear. Now let us go and identify what it is. Intermediate actually carbocation, carboanion, and free radical or transmission state. So these are the points are there in that intermediate state. Okay, what is intermediate state? First and foremost, intermediate state actually it is intermediate product actually it is more reactive comparatively parent compounds, because these both combine to give as an intermediate compound. Intermediate compound it is more reactive. A phenol is actually phenoxide, it is more reactive than phenol, right? The same way here, intermediate product it is more reactive than substrate and reagent. Okay, this intermediate compound combined with some substituent group, then you will get a final product. Okay, now this intermediate compound, what are the intermediate compound? Carbocation, carbanion, free radical, and one more thing, transition state. So these are all the points we are going to go through with this session. Hope you will understand all these points one by one. Okay, let us go and identify. Mainly, we are talking about reaction mechanism in organic chemistry. In that, organic compounds are generally what it is covalent bond in nature. Okay, covalent bond in nature, we are talking about sharing the electron. That means sharing the electrons each other. Right. Now, in this point, I would like to mention step-by-step process. First and foremost, electron displacement. Why we are talking about electron displacement? No, here electronegativity. Why do we talk about electronegativity? Due to the different electron densities. So higher electronegativity, lower electronegativity. In that way, from lower electronegativity, electrons are moving, displacing to higher electronegativity. In that way, we are going to talk about electron displacement. Definitely cleavage taking place, bond breaking. So then next one, nature of the reagent. Just now we have gone through nature of that electrophile, nucleophile. Okay, these are all the points to be noted while doing that, what it is, reaction mechanism. Okay, due to the different electron densities, the substrate molecules are getting some effect. So what are the effect we are going to get it from the substrate? Let us go one by one. The first one, inductive effect. Inductive effect. Okay, second one, electromeric effect. Electromeric effect. Then third one, resonance. Resonance and mesomeric effect. Meric effect. Okay, then the last one, hyperconjugation. Okay, so all these effect we are going to go through step by step process. Hope you will get a clear idea about it. First and foremost, the great inductive effect, because here generally covalent bond formed due to the contribution of electron by two atoms. Okay, so the two atoms, if it is similar, what bond formation? If it is different atoms, what is the bond formation? Come on, let us go. Okay, first and foremost, the two atoms are similar. Similar means here non-polar, non-polar covalent bond. We are talking about covalent bond formation, right? Okay, non-polar. What? Give that example of non-polar. Generally, diatomic molecules. See here, H2, Cl2, here carbon and carbon connected with that. So these are all generally what it is, non-polar molecules. Okay, now for example, hydrogen bond. Here, hydrogen, chlorine, here chlorine. So in that way we can identify. So this is Okay, now the two atoms are dissimilar. That means different atoms. So what happened here? Polar bond. See, even in the chemical bond also you will learn the same way. Okay, so polar bond. So polar bond in the covalent. Okay, so polar bond means, give that example. So here carbon connected with halogens. Here carbon connected with oxygen. So these are all polar bond. So polar bond molecules. Okay, now here this is a substituent group. When we are talking about that substituent group which is connected with carbon, actually both are having what it is, electronegativity group only. Okay, but in that which is having more electronegativity, which is having less electronegativity, that only it is a matter. Okay, now what happens? So definitely electron displacement reaction takes place. Electron displacing, that means sharing electrons only, it is going forward to compensate. So electrons from carbon, electrons are going forward the same way here. So what happened? The arrow mark goes forward to that halogen. So here dipole interaction takes place. Dipole interaction, that is very important. You have learnt already in the dipole moment, that and all you have learnt. Okay, now the dipole interaction takes place. So what happened? A slight variation, slight difference. So naturally here donating this carbon, it is donating to the halogen. That means electrons are moving forward to that halogen. So here minus charge and here plus charge, but slight variation only. That is what del minus, that means delta negative and here delta positive. So due to that, generally this polar bonds, generally this happens in that number of carbon chain only it happens. Okay, now we'll go and identify where the polar bond it's happening, where it is going to identify. These are the 2 points we are going to see to that. From the polar bond, we got two main ideas. The first main idea, which is a different electronegativity among the atoms. The second one, electrons are shifting from lower electronegativity atom to higher electronegativity atom. So those two main points which leads to inductive effect. So what do you mean by inductive effect? Inductive effect as a pull of electron density through sigma bond. Note the point, sigma bond causes by electronegativity difference by atoms. Okay, now for example, carbon connected with halogen. So when we are comparing with carbon and halogen, halogen is having more electronegativity than carbon. So naturally electrons are shifted towards that halogen. So naturally you will get that negative charge on that halogen. So naturally here slight variation, here del positive and here del negative. So this is happening that carbon chain only, end of the carbon chain, the substituent group of that atom will be attaching. That to what it is, more electronegative atom or group. So here atom halogen, it is an atom which is attached at end of the carbon chain. Whereas here group means nitro group or cyano group and carboxylic acid. So these are the groups which may attach with that, because it is electron withdrawing atoms or group which is attached to that. So naturally, as the number of carbons which is increasing, as the effect decreases as the distance increases. So the inductive effect decreases as the distance increases. Here it will be more power, but as the number of carbons are increasing, the effect will be decreasing, the power will be decreasing. See, comparatively, this is the first carbon which is having positive charge, which is having more power. But when we comparatively, here del 2 del positive, here 3 del positive, so here very less. Okay, comparatively this carbon and here negative charge. Anyway, this is attached with that end of the carbon only. Please note that point. So these are all the groups which is having electron density, electron negativity will be more. Electron withdrawing groups, they will say. Hope you're clear idea about that inductive effect. What is it inductive effect? From where we are getting that inductive effect? What are the points to be noted for that inductive effect? Now we are going to see what are the different types of inductive effect. Now, inductive effect means shifting of electron and electron negativity difference among the atoms. These are the 2 points to be noted when we are talking about inductive effect. Okay, inductive effect is divided into two groups, that is minus I effect, plus I effect, based on the carbon hydrogen bond as a standard for comparing the tendency of an electron attraction and electron repulsion. So due to that electron attraction and electron repulsion, okay, so here moving forward to lower to higher, I just mentioned the same way here, attraction and repulsion of electron, here minus I effect, plus I effect. What is it minus I effect? Minus I effect, it is nothing, atoms or group which has what it is, more power to attract the electrons. So more power to attract the electrons in comparison to hydrogens, that is minus I effect. Whereas plus I effect, atoms or group which has less power to attract the electron than hydrogen. Okay, now what is the main point here? Minus I effect means electron attracting group. Minus I effect, it is nothing, electron attracting group. Electron attracting group, it is electron withdrawing group. Generally in mechanism, EWG, that is electron withdrawing group, usually we will write electron donating group or electron withdrawing group. That is nothing. Minus I effect is known as electron attracting group or electron withdrawing group. Please note down. The second one here, plus I effect, electron repelling group. So it is repel. Okay. So electron repelling group or electron donating. Okay. You take that electron like that. It is donating. So that is electron donating group. Okay. Now we are going to see the decreasing order of that among the molecules. Minus I effect, plus I effect very clearly. Here, minus I effect means electron attracting or electron withdrawing group. Okay, now where do you identify that minus effect? Here, positive charged and most unsaturated groups, it will be present. Okay, now we are going to see the decreasing order of that minus I effect. So, decreasing order means here most electronegativity group only decreasing order. Okay, which is the most electronegativity? Just we mentioned here positive charge, no? So NH3 plus, okay, so that is greater than CF3. It's greater than nitro group, okay, which is attached that carbon chain, long chain, no? Okay, nitro group, which is greater than cyano group, which is greater than carboxylic acid, which is greater than acetyl chloride, which is greater than aldehyde. Aldehyde, it's greater than ketone, which is greater than most electronegativity group only now. Have atoms also we can mention. So fluorine, chlorine, which is attached to carbon chain. Okay, fluorine, chlorine, bromine, greater than no bromine, and iodine, and alcohol OH. It's greater than OC6H5. It's greater than OR. It's greater than amino group NH2. It's greater than C6H5. It's greater than what it is? Hydrogen. Now, which is the most and which is the least, we can come to know very clearly. Okay, I'll tell you once again very easily, quick point you can grasp. First and foremost, most positive charged NH3 plus CF3. It's greater than nitrocyanocarboxylic acid. Nitrocyanocarboxylic acid. Next, acetyl chloride aldehyde ketone. Acetyl chloride aldehyde ketone. Then third point, fluorine, chlorine, bromine, iodine. Then alcohol C6 OC6H5 and OR. Here C6H5 OR means methyl. Okay, OC6H5, OR, amino group, phenyl group, and hydrogen. So hydrogen is the least inductive effect. So which is the most and which is the least? Hope you are clear with that minus I effect and decreasing order. Okay, now we are going to see the plus I effect of examples. In the plus I effect, electron repelling group or electron donating group. Okay, where do you identify that group? Negative charge group and different types of alkyl group. Okay, generally here positive charge we mention, no, here naturally negative charge group. Wherever negative charge group, that belongs to plus I effect. And different types of alkyl group, they have given the clue. So easily we can identify tertiary, secondary, primary, methyl. In that way we can go. CH3 thrice C, it's greater than CH3 twice CH, it's greater than CH3 CH2, it's greater than CH3, it's greater than D and H, it's greater than O minus, it's greater than COO minus, and it's greater than alkyl. Okay, so these are all that decreasing order of plus I effect. I hope you got a clear idea about plus I effect and minus I effect. Sorry, minus I effect and plus I effect. So what are the groups will be present? What are the groups belongs to that minus I effect and plus I effect? You got a complete idea. Okay, now we are going to see that four main points: stability of carbocation, stability of carboanion, acidity of alcohols and carboxylic acid, and basicity of amines. These are the four main points we are going to discuss. Now we are going to see that carbocation. Before going for all these points, how do we get carbocation? See, reactant and substrate combine to give up intermediate product and final product. We have gone through that. Okay, now this intermediate product only divided into 3 or 4 groups, that is carbocation, carbon anion, free radical, and transition state. Okay, now in this carbocation, how do we get that carbocation? Here actually dissimilar atoms, that is called polar bond, we have gone through, no? So polar bond, that is leads to what it is, inductive effect. From there only we are collecting, that is what it has mentioned, hydrolysis. Hydrolysis means different, okay, different kind of atoms. So different kind of atoms of carbon and halogen bond can generate carbocation. How do we get that carbocation? Giving 2 electrons to halogen atom. Now carbon is there means here halogen which is attached, the electrons, this 2 electrons also it is donating, that means the electrons are attracted towards that halogen. Why? Because halogen it is having more electronegativity. Carbon, comparatively carbon, it is having less electronegativity. So naturally the electrons are going forward, attracted by the halogen. So it is giving 2 electrons to halogen and generate positive charge. Why? Because it is donating, automatically getting positive charge. So this positive charge on carbon has an intermediate. This is actually intermediate because this is going to attach with some other component to form a final product. So this is called carbocation. Okay, now carbocation, how do we identify the stability? So the number of carbon increasing, stability of carbocation also will be increasing. Okay, now here plus I effect, minus I effect. So plus I effect, it is directly proportional to stability of carbocation. I just mentioned C plus. C plus means carbocation or carbonium ion. The same way, minus I effect, it is inversely proportional to stability of carbocation. Okay, so as the number of carbon which is increasing, so naturally stability of carbocation also will be increasing. Okay, now plus charge, as I mentioned, CH3 plus, it's lesser than CH3 CH2, it's positive charge, it's lesser than CH3 CH3, here methyl, here methyl, here primary, here secondary. So the carbocation where the carbon it is there, there only we can identify. Okay, now this is secondary and this is tertiary. CH3, CH3 and here CH3 and here positive charge. Okay, so here secondary and here tertiary. So in that way, we can identify the carbocation stability. Number of carbon which is increasing, stability of carbocation also will be increasing. That is what plus I effect. Minus I effect, it is inversely proportional to the stability of carbocation. Hope you are clear. Okay, we will go for some more examples related to this point of stability of carbocation. Here, plus I and minus I, as I mentioned only, now I would like to give some more the same ideas only what I have given that examples of plus I and minus I effect. Okay, now here, NH3 plus, here CH2, positive charge. And here, lesser than, we are talking about increasing order, no? So here positive charge. NH3 always positive charge. Okay, now here NO2. Here CH2 positive charge and here carbocation positive charge like that you just mentioned. Okay, now here Cn CH2 positive charge. Okay, now fluorine, chlorine, bromine, iodine. Okay, now here CH2 fluorine positive charge and here chlorine CH2 positive charge. You just go through in a proper way so that you will come to know very clearly where there is more electronegativity. In that way you can go for it. Okay, now next one. Here fluorine, chlorine, bromine and CH2 and here iodine and CH2 positive charge and lesser than. Here one more idea I would like to give you. Here CH2 positive charge, here NO2. Okay, it's lesser than. Now you see the position where it is coming. Okay, I'll rub this. Okay, the same way here CH2 positive charge and here NO2. Okay, now another one more. CH2 positive charge and NO2. Okay, now you see where and all it is coming, it is lesser than. So this is the way you can identify the stability of carbocation. How do we identify clearly? Okay, now when we are talking about this in that minus I effect, minus I effect it is what it is inversely proportional to the stability of carbocation. As we are writing lesser than, now you go for the greater than, just the opposite of minus I effect. Hope you're clear. Okay, anyway, we'll go for the carbo anion, what it is. Now, I just give that idea. Hope you're clear with it. If you want, you can take that screenshot also. See, if you're getting that order, if you know this order in that objective type questions, you are able to answer for it. Please keep up this point. Okay, now we are going for the carbon anion. Hope you're clear with that carbocation. Here the same way, how do we get the carbocation? In that way we are getting carboanion. Carboanion, it is what it is, receiving electron from the other. Okay, that what it is, two different atoms. Hydrolysis of carbon and base can generate carboanion. Giving two electrons to carbon atom and generate negative charge to that carbon, it's called carboanion. Okay, now carbon which is connected with base. So these two electron connected over here. Okay, now this is actually more than that base which is having more electronegativity towards the so electron which is attracting by the carbon. So naturally here carbocation, here what it is, electrons are going towards that halogen. So 6 electrons will be there. 6 electrons will be there. So naturally you are getting what it is, electron deficient, electron poor, deficient. Okay, but whereas here electrons are coming towards here, so that means here already 6 is there and here 2. So 8 electrons. So that means this is electron rich. So electron deficient and electron rich, I hope you will come to know. This is what it is. I just mentioned the symbol and this is what it is. Now, I hope you got a complete idea about what is carbocation and what is carbon anion. Okay, so carbocation, it is nothing, electron deficient. Anion, it is nothing, electron rich, which is also known as nucleophile, and this is electrophile. Electrophile, and this is nucleophile. I hope you got a clear idea about what it is carbocation and what it is carboanion. How many electrons present in that carbocation and anion? Very clearly. Here only 6 electrons are there because 2 electrons which is given to that halogen. I am comparing carbocation and carboanion. Okay, but here, whereas here the base, it is donating 2 electrons to carbon, so naturally 8 electrons are there. 8 electrons, and naturally it is completely filled the octet structure. So electron rich. So naturally it is nucleophile and this is electrophile, electron deficient. Hope you're clear. Okay, now we are going to talk about stability of carboanion. Okay, stability of carboanion, just the opposite to stability of carbocation. Here, plus I effect, minus I effect. Before I could say the answer only, you are knowing that answer very well. Okay, plus I effect, it is inversely proportional to stability of carboanion, negative charge. The same way here, minus I effect, it is directly proportional to stability of carboanion. Okay, now as the number of carbon increasing, stability of carboanion which will be decreasing. Okay, now you see here CH3 minus charge, it's greater than here CH3 CH2 minus charge, it's greater than CH3 CH3 minus charge, it's greater than CH3 CH3 and here CH3, here minus charge. Okay, now as we are talking about this number of carbon which is increasing, this is most and this is least. Okay, now here, as the number of carbon atom increasing, stability of carbon anion which will be decreasing. So this is methyl primary, and this is secondary, and this is tertiary. So number of carbon atoms increasing, naturally that stability of carbon anion which will be decreasing. Okay, now some more ideas, we'll go for it. Here CH2, here NO2. Okay, now this also is negative charge and that is greater than here cyanide group Cn, here CH2. Please note down all this, it's common. Okay, greater than here, and fluorine, chlorine, bromine, iodine, of course those are halogen groups. Okay, now here CH2, here fluorine minus charge, it's greater than fluorine, chlorine. Here Cl, CH2 minus charge, and here bromine, Br, and CH2 minus charge, and iodine. Okay, here I, here CH2 minus charge. Okay, fluorine, chlorine, bromine, iodine. Okay, now some more ideas, like for example here CH2, in this Cn. Okay, now here minus charge. Now the same way here, it's greater than here Cn, here CH2 minus charge. Now you see minus charge. Okay, you see that where the position. Okay, in that way we can go for it. Hope you're clear with this carbocation and carbanion. Okay, I hope you're very clear about what is carbocation, stability of carbocation, and the same way what is carboanion and stability of carboanion. You know thoroughly, I hope so. Okay, now the next one, acidity of alcohols and carboxylic acid, and basicity of amines we will go through in our next topic. Hope you're clear with this all. Thank you for watching.